Hello guys, so this video belongs to risk assessment for excavation works. We will be discussing about how the risk assessment is prepared for excavation works, what are the hazards, what is the risk, what is the calculation of risk, how to calculate the residual risk, how to provide the control measures. So all the things we are going to discuss in this particular video. So let's talk on how the control measures to be applied before assessing a particular risk. So this is the hierarchy of control measures which shows most effective control to the least effective control measures, which is actually used to bring down the risk level as low as reasonably practicable. So by application of elimination control, substitution control, engineering control, administrative control, and last one is the PPE, we are trying to bring down the risk as low as reasonably practicable. So let's understand what is risk assessment first. So risk assessment is a systematic approach or process used to identify and evaluate potential hazards, assess the associated risk, and determine appropriate control measures to prevent or minimize the harm. Here's a general procedure for conducting a risk assessment. So the step 1 is identify the hazard. First we need to identify all the potential hazards that exist in the workplace or the specific task or activity being assessed. This can include physical hazard, machinery or chemicals, biological hazard, pathogens, ergonomics hazard, repetitive movements, and psychological hazards, work-related stress. Let's come to the step 2, which is identify those at risk, who can be harmed and how they can harm. So determine who may be exposed to the identified hazards. This includes employee, contractors, visitors, or anyone else who may be present or affected by the hazards. Let's come to the step 3, which is assess the risks. So we need to assess the naked risk first without involving the controls or without considering the existing controls. So we need to calculate the naked risk, evaluate the likelihood and severity of harm that could result from each identified hazard. Consider factors such as frequency and duration of exposure, the potential consequences of an incident, and the vulnerability of individual exposed to the hazard. Use a risk matrix or other tools to determine the level of risk associated with each hazard. So next step 4 is evaluate existing control measures. In step 4, we need to review and assess the effectiveness of existing control measures that are already in place to mitigate the identified hazards. Determine if the current measures reduce the risk to an acceptable level or in further actions are necessary. The next step 5 is determine additional controls. If the existing control measures are not sufficient or if new hazards are identify and prioritize additional control measures that can be implemented to further reduce the risk. Consider hierarchy of controls, which includes elimination, substitution, engineering controls, administrative controls, and personal protective equipment. Step 6 is communicate and consultant. Engage with workers, supervisors, and other relevant stakeholders in the risk assessment process. Communicate the findings, control measures, and any necessary changes or actions. Seek input and feedback to enhance the effectiveness and ownership of the risk assessment process. The step 7 is monitor and review. Regular monitoring and review the implemented control measures to ensure their ongoing effectiveness. Assess if the risks have been adequately reduced and if any new hazards or changes in the workplace require reassessment. Periodically review and update the risk assessment as needed on when significant changes occur. So this is the HIRA register format on which we are going to do the risk assessment. So this document shows you how the risk assessment format will be. So the first column you can see, which is the serial number. Sub activity means if we are taking example of excavation works, so in excavation what are the sub activities are there, or what are the all the activities which are contributing to the entire excavation work will be mentioned. Next column is hazard. So with respect to each activity we need to identify the hazard. Then in next column hazardous event is there. So with respect to each hazard we need to consider the hazardous event, and in the next column there is a possible outcome. So against the each hazardous event what will be the possible outcome will be mentioned. Next we need to calculate or consider how many populations at risk is there. Suppose 2 persons are there, 3 are there, 4 are there. Accordingly in next column there is a probability rating. It means what is the likelihood rating will be considered from RAM, risk assessment matrix. Next severity rating, which also will be considered from the risk assessment matrix. Then in the next column we have risk level. So risk level shall be calculated by using the risk assessment matrix. After considering all the things, this was a naked risk area. Now we need to consider the existing control measures. The control measures which are there by existing conducting the activity. If the existing control measures are not sufficient, not adequate, then we need to go to the additional control measures if we are unable to reduce the risk level. Then the remaining risk will be the residual risk, and in next column there will be action by. So let's understand this format using a adequate example of excavation work. So in excavation, let's take a first activity and hazard. The first hazard will be underground utilities. What can be considered in underground utilities are pressurized lines, electrical lines, or any gas lines. So you can see while conducting a excavation, in pictures you can see there are lines which are there underground, and that may pose to harm if a person coming in contact of these utilities. What is the hazardous event? Contact with utilities and bursting of pressurized water sewer lines, contact with electrical cables which may cause electrocution, leakage or gas lines. So what will be the consequences out of this hazardous event? A person may get the personal injury. Due to electricity, he may have the electrocution, and same may lead to lost time injury. So let's calculate what is the exposure or population at risk. Suppose there are 4 persons working in the excavation area who may be exposed to these underground utilities. Let's take what is the likelihood or probability. So the likelihood or probability we are considering without considering the existing control measures. So suppose there is no control measures are there in a place. In that case, the likelihood of getting contact with these underground utilities is P4. So by using the below risk assessment matrix, we can see P4 means it may happen often or most likely. Let's come to the severity level. By using this risk assessment matrix, severity has taken S5. It means fatality. So these likelihood and severity has been considered without considering the existing control measures. So what is the naked risk level will be by using this risk assessment matrix? It is H, means it is high risk. Let's come to the next level or next column, which is existing control measures. So in utility portion, if we use the cable detector or utility detector, so by using this engineering control, we can eliminate the hazards right? Second, if trial pits are done, by using trial pits we can identify that there is underground utility. Third control measure, excavation clearance work permit shall be followed. So this comes under administrative control. Fourth control is person provided with mandatory PPEs. So the person who are engaged in excavation work are provided with mandatory safety shoes, which is approved IS 15298. Safety helmet, which is 2925 approved, and reflective vest. So applying of these existing control, we are able to bring down the risk level. So what is the reduced risk is P1 and S5. So now likelihood has been reduced from P4 to P1. Now P1 means is most unlikely or rare. If we are applying this existing control in the excavation, now there won't be any contact with the underground utilities and it won't be leading to LTI or personal injury or electrocution to the particular workman. So now the reduced likelihood level is P1, it means most unlikely, and severity is again S5. So S5 means again it is fatality. Now this is to understand that by even applying the existing controls, I haven't reduced the severity level. It is why, because severity cannot be reduced by applying the existing control or control measures. The reason is, in case this existing controls get fails, then definitely the person will be reaching to the or leading to the or going to have the fatality. That's the reason we haven't reduced the severity, but we have reduced the likelihood from P4 to P1. It means now the risk has come to the M, means medium risk. So we have reduced the risk from high risk to medium risk level by using this risk assessment matrix. Let's come to the second hazard in excavation, which is harmful toxic gases, fumes, and the second one is the confined space. So this hazard can contribute or lead to a hazardous event. So due to this particular toxic gas or fumes, it may be inhaled or inhalation of harmful toxic or fumes by a workman. So this may be a hazardous event. If we talk about the consequences due to inhalation of harmful gases, the person may get sick, ill health, lost time injury, and fatality also. Let's come to the exposure and population at risk. So same, we have considered that 4 persons are working in the excavation area. Now coming to the likelihood level or probability. So without considering the existing control, we have considered P4. It means often or most likely. Means these harmful gases or confined gases environment may be available most likely in the excavation. Now severity S4. It means it is major injury or may convert into amputations. And now the risk, naked risk level is considering P4 and S4 in risk assessment matrix comes to H, means high risk. Now our intention is to reduce the risk level by application of control measures. So let's apply the control measures for this particular hazard. So if where the gases and fumes are likely to present in a trench or test shown their presence therein, sufficient mechanical ventilation to protect the health and safety of person working there shall be provided according to IS 3764. Multi-gas detector shall be used to check the concentration of oxygen, carbon monoxide, carbon dioxide, hydrogen sulfide and NO2 level. Air shall be considered unfit for workmen to breathe if it contains any of the following: less than 19% of the oxygen volume, more than 1% of carbon dioxide by volume, more than 0.01% of carbon monoxide by volume, more than 0.002% of hydrogen sulfide gas, more than 0.002% of nitrogen oxide gas by volume. So these all data are as per IS 3764, which is for safety in excavation. Now these all controls comes under engineering control. Let's talk about the administrative control. So trained personnel are allowed to work inside the trench and confined space area. And let's come to the least effective control, which is personal protective equipment. So the last one is mandatory PPEs by workmen shall be worn while conducting the excavation works. So the photos of in control, it shows we are using the multi-gas detector, which shows the LEL and UEL percentage of the gases. So by applying these control measures, we have reduced the likelihood by P1 and severity is same S4. By applying this, we have reduced the risk level from high to low level. Let's come to the next hazard, which is vertical cut, improper slope of excavation soil or wall. So this particular hazard will be leading to the hazardous event, which is collapse of soil, collapse of adjacent structure. So by images also you can see this particular hazards may lead to this hazardous event, and this hazardous event will be leading to consequences in terms of personal injury, lost time injury and fatality as well. Let's consider the exposure of population risk. Same, 4 persons are working still. Likelihood or probability of getting vertical cut, improper slope of excavation of soil is P4, but it is often or most likely possible. Hazardous event, if we talk about the severity level, then S5, it means it will be leading to a fatality if collapse of soil and collapse of adjacent structure. So the naked risk by application of this risk assessment matrix come high level. Our intention is to reduce the risk. We are applying the control. Let's apply the control measures in this particular area. The one is adequate slope or benching of excavation wall to be maintained as per type of soil. So these controls are as per OSHA reference. So OSHA, the types of soil has been mentioned as per OSHA in this, and what is the vertical ratio or slope to be maintained according to the soil has been described in the picture. Second, approval from structure consultant required for excavation, shoring or sheet piling to be done as per the structure consultant remark. The next control is approval from Ministry of Coal and Mines under Haryana or any state mining rules, wherein up to 500 square meter or 1.5 meter in either case, no approval required. So when in there, you are going to excavate a major area of excavation which is above 500 square meter or more than 1.5 meter, you need to take the mining license from the agencies of government. Next administrative control we come under is trained personnel are engaged in excavation and workmen are engaged in mandatory PP is the least effective control. So the image shows that if it is a type A type soil, then 53 degree slope shall be maintained. If it is type B type of soil, then 45 degree of slope shall be maintained. If it is type of C, then 34 degree of slope need to be maintained. So by application of these control measures, in image also you can see the benching has been done. Benching is made properly step by step. So now the chance of collapse of soil has been reduced. Now the residual risk is medium. How? We have reduced the likelihood level from P4 to P2. Now it is unlikely if we have done these control measures, and the residual risk is medium. Let's come to the next hazard, which is soil cave-in. So there is a cave-in in a soil by which hazardous event will lead to collapse of soil, and the consequences will be less lost time injury, fatality, property damage, and exposure of population risk is same 4. Likelihood is P4, yeah, means it is often or most likely possible, and severity is S5. It happens, then it will be leading to fatality, that's why it is taken S5. So this naked risk level gives us the number of H, which is high level risk. So now we need to reduce this high level risk to a medium or low level using a control measures. Let's apply the control measures in this case, where the caving can be done is first, adequate benching or slope shoring to be provided as per structural consultant remark and as per IS code reference, which is 3764. In below images you can see the sheet piling is done, and trained workmen are allowed with display of signages and PTW clearances, which is an administrative control, and the least effective control is mandatory PPEs to the workmen. So by application of these control measures, the residual risk is P1, means the likelihood is P1, and the severity is S4, which is same before the control measures. So now we have reduced the risk to the medium level by using the risk assessment matrix. So let's come to the next hazard, which is vehicle movement. Yes, vehicle movement is a hazard which may lead to hit by vehicle, collapse of vehicle, fall into the excavation pit. Let's come to the consequences. So by vehicle movement, if this hazardous event, hit of vehicle, collapse of vehicle, fall in excavation pit happens, it will lead to LTI, fatality, property damage, and exposure is same for likelihood or probability. If vehicle movement goes into hit by vehicle or any hazardous event will be P4, means often or most likely possible. Likelihood, probability, and then severity S4, means it will be leading to major injury or amputation. So the naked risk level gives us a number H. It means it's a high risk. We need to bring down the risk level, and the control measures need to be applied as per hierarchy of control measures. The first engineering control is hard barricading shall be provided at the edge of the excavation. In vehicles, reverse horn and the other safety devices equipped in vehicle which is functional. Vehicle to be parked 1 to 2 meters away from the excavation edges. Unauthorized entry shall be restricted, which is the administrative control. Flagmen shall be deployed and competent driver shall be deployed. So by using these control measures, now the likelihood has come to the P1, means it is rarely or mostly unlikely if we use the control measures, and the severity level will be same as 4, because we haven't reduced the severity but we have reduced the likelihood level. Now the total risk level is L, from high to low. Let's come to the next hazard, which is dust in the excavation. So dust is the most prominent hazard which we see, but we take it very likely, and this particular dust may be inhaled by the workmen. So inhalation of dust may cause to ill health or respiratory diseases. The next hazard comes to the open excavated edges, means unprotected excavations. It may lead to fall of vehicle, fall of person and material. In first case, means in dust hazard case, we have taken a consequences of ill health or respiratory diseases. In seventh one, we have cases of personal injury or LTI case. In both the cases, we have considered the exposure, which is same, 4 persons have been employed, and the likelihood in the dust case is P3. It means it's likely possible where the workman may inhale the dust, and severity will be S3, means moderate, or LTI, means long term in chronically it may harm to the person in respiratory diseases. And the risk or naked risk level is medium in dust case. In open excavation case, the likelihood is P4 and the severity is S4, which gives us the number of high risk. Now we need to bring down the risk level by application of control measures as per hierarchy of control measures. So if we apply the control measures in the dust, so the first control is regular water sprinkling to avoid the controlled dust exposure, which is an engineering control, and the second one is the provision of dust mask to the workmen, which is an least effective control. So by application of this, we have reduced the likelihood and the number is low risk with application of risk assessment matrix. In the second case, where the open excavation edges was there, we have done hard barricading shall be provided for excavation with top rail, mid rail and top board. The second control is cautionary hazard warning signages to be displayed. By application of this control in open excavated edges, the likelihood has been reduced to P1 and the severity is S4. Now the total number gives us the low risk, it means we have reduced the likelihood and we are able to bring down the risk level as low as reasonably practicable, which is low risk.